Hi, welcome to this tutorial in which I will guide you through the composition of a workflow in EDGELESS. EDGELESS is a European project which has the ambition of enabling serverless computing at the edge on devices with limited capabilities. For this tutorial, you will need the code of the reference implementation of EDGELESS, which you can get at GitHub. And you need to build the code. You can check the instructions that are shipped with the code itself. If you want to have more information, you can check also our website. So let's assume that I already have the code in my local working directory. And as a matter of fact, if I try to build it using the carco command, because the code base is programmed in Rust, I get it is done immediately. You can ignore the warning there. Then for this tutorial, we'll use an example called tutorial 01. This tutorial is intended to create the following workflow. A workflow in EDGELESS is a composition of functions. In this example, we have two main functions, which are the filtering range and the moving average. The functions do the processing part of a service, which we want to enable. In particular, this filtering range receives as input a number, and it checks that the number is within a validity range that we want to define as part of the composition of the workflow. If this is the case, then an event is generated towards the next item in the graph, which is the moving average, which keeps a window of past values. And then, based on the configuration, again done at the workflow composition time, it creates an output that consists of the average of the values received, which are saved to a Redis server that is external to the system. In EDGELESS, we have those green boxes, which are resources, which are like functions, so they can have some processing, but unlike the functions, they also can have side effects into the real world. So while the filtering range and the moving average only live within the EDGELESS system, the Redis, for instance, it does something which affects the environment external. And the same goes for this file log. So in this case, if the filtering range detects that the input number is not valid, it will send it to this file log, which will simply write down the error message on a local file. In addition to the filtering range, moving average functions, and the Redis and file log resources, we also have a sensor simulator function here, which is only needed for the purpose of testing the workflow, because I don't have available a sensor that can actually produce data in EDGELESS. So this simple function will generate pseudo-random data that will be provided to the input of the real workflow, which starts here, and is the following. Let's see how all of this can be done in EDGELESS. In the tutorial 01, you will find already all the individual functions that are needed. So the sensor simulator function, the filtering range function, and the moving average function. You will not find the file log and Redis because the resources are provided by the system itself. So you don't have to worry about them. You can just use those special resources. Each function comes with some source code, which we are not interested into in this tutorial, and with a specification of the function that says the identifier, the function type, for now, the only function type that is supported by EDGELESS is WebAssembly through Rust bindings. The version, the manifest where you can find information on how to build this function into bytecode, and the output callbacks or channels. For instance, in this case, you can see that the moving average function and the filtering range function, they both have two channels which are used to pass to call the next function on the output or the error for the filtering range. It is not mandatory to connect all the channels. So for instance, for the moving average, we might want to simply move on the value on the output without connecting the error channel, which would be here. The workflow can be composed using JSON. Now we will go through the JSON file. The JSON file that specifies how the workflow is composed consists of 4 sections. The first one is very easy, alias. This is just a shorthand for the workflow, a name. Then we have the list of functions that will be composed, which in our case is the sensor simulator, the filtering range, and the moving average. Those are the 3 functions. In each function, we have the structure is always the same. There is a specification of the function which copies most of the data from the function specification. So if we go into the sensor simulator here and we have a look to the function specification, we will see that the identifier is the same, the function types is the same, the version is the same, and the callbacks are the same. The only thing that differs is that in the specification of the function, we have to specify how to build the function into bytecode, while in the workflow, we assume that the bytecode has been already built and we just specify where it can be found in the local file system. So this is just a location of this sensor simulator.wasm file that has to be available at the time when the workflow is created. Then we have this output callback definition, which is very important because this is where we specify how to combine together the functions and resources. So in this case, by mapping output to filtering range, we are saying that the sensor simulator here should map this output channel to the filtering range function. So this is how we interconnect the functions into the resulting workflow graph. And as a matter of fact, we can skip the specifications in all the functions and just focus on these callback definitions, as we see that the filtering range will map the output to the moving average here, and will map the error to the file log here, while the moving average will send the output to Redis. And in this specific workflow JSON that we have on GitHub, we are also mapping the file log, which if we don't want, we can simply skip, and the error channel will be left unused in this workflow instance. Additionally, for each function, we also have a field called annotations. This is a JSON object which can have multiple values or can be empty. It is empty for the sensor simulator. For the filtering range and the moving average functions, we use the field special field init payload. This is used to initialize the configuration of the function instances. Specifically, for the filtering range, we are providing the range from 0 to 100, that is the validity range for the filtering range, while for the moving average, the function expects to find in the init payload the number of values that have to be used to compute the average. In EDGELESS, note that the functions can be stateful. This is different from most serverless computing platforms where the functions are typically stateless. The state can be constant, and in this case of the filtering range and moving average, this constant state is used to initialize the configuration of the functions, or can also be dynamic. So it is possible for a function to keep some state that is local to the function instance, and that it can change and adapt over time until it remains alive in the system. In the case of the moving average function, we use this feature to keep a window of the previous values to create the average. This is done inside the function definition of the moving average, which we will not see in the tutorial. So to summarize, in the function section, we specify which functions we want to use, where to find the code of the bytecode of the function, as it is seen here, and we specify how to interconnect one function to another into the workflow. What we are missing now is the resources section, which completes our workflow. In this section, we add resources, which again are special functions for which you don't have to specify the location of the bytecode, because this is provided by the system itself. You only have to specify the type of resource that you want to use, file log or Redis, and you specify the configuration inside the configuration section, which in the case of the file log is the name of the file where to save the error messages. And for the case of Redis, which is an in-memory database, we specify the URL where to find the service, and the key where we want to save the output. There is also a last section called annotations, which in the future will hold quality of service requirements and characteristics for the workflow. For now, it can be left empty. And this is how the workflow JSON file is created. If we want to deploy the workflow, then we need a few things. First of all, we need the compiled bytecode for each function. This can be created using a command line utility provided within EDGELESS, which is the EDGELESS command line, where we can build a function by specifying the location of the function JSON corresponding. In this case, for instance, let's try to build the filtering range function. This will compile the source code of the filtering range function, which we have covered in another tutorial, and it will create the bytecode in Rust WebAssembly. If we go now into the examples tutorial 01 filtering range, we will see that there is a filtering range WASM file that was not present before, that we will use to deploy the workflow into the EDGELESS system. And we have to do the same for all the other functions. So the moving average function, function build, takes just a moment, and then we have to do the same also for the sensor simulator. Meanwhile, we can check on another window that the tutorial 1 key that we want to write to the values in Redis, in our local Redis that I prepared, is empty for the moment. And there is no reading those.log file for the time being. After the functions will be built, then the second thing we need is an EDGELESS cluster. If you don't have an edges cluster ready, you can create one by just running the edgeless in a box. Edges in a box is a minimum implementation of the core edges components all together in a single binary that is very useful for testing purposes. We can run it with a Rust log here. This edges in a box requires a number of configuration files, which are this one. These files, if you don't have them already, can be created as specified in the instructions to build in our GitHub repo by using the edges in a box -d command, which creates these templates for the configuration files. Now we have a working edges cluster, and we can use again the command line interface to create the workflow. In this case, the command will be workflow start, and we specify the location of the JSON file that we went through before. The workflow has been accepted by the system, and which returned to us the identifier of the workflow that we can use, for instance, to stop the workflow later. As you can see, there is a lot of log going on. If this can be confusing, we can bury the terminal for now. Now, if we go and check what is happening in the external world to Edgeless, we can see that there is a reading errors file. And if we go there, we'll see that there are new lines that are added with all values that are out of the range 0-100 that we have configured. As you can see, that are all negative numbers. And this is correct since we want to discard those values into this file log. On the other hand, if we get the latest value on Redis of the tutorial 01 key, we get 45. And this is what has been produced as output by the moving average. This value, of course, will change over time as new numbers come and the window gets updated. At this point, if we want to stop the workflow, we can just issue a stop command by passing the ID that was returned to us by the system, and this will stop the creation of the values. And if we go again into this section, we can see that all the mess is now has now stopped. So in this tutorial, we have seen how the workflow JSON file to compose a workflow is created by using as example a workflow with 3 functions and 2 resources, and how to run it in a debug environment where you have all the edges components as a single executable, called edges in a box. Thank you for your attention.